Alright, hi guys, Mrs. Rona here again, and I'm going to show you the second method for solving proportional reasoning problems, and that's using equations and proportions. So hopefully you already watched the other video and you understand where we got to the equation of delta y is equal to half acceleration times squared. So that's the equation we're using for this specific scenario because it relates time and height, and we talked in the other video about why the initial velocity factor falls out here. So same thing we did in the other video. When you do any proportional reasoning problems, you need to have an original setup and then what the new setup is. So in this problem, the new setup is twice the height. So I label that as 2 times delta y. So in the original equation, that's the equation we're using, and I'm going to write that down for both of those because that's the proportion in both cases. That equation can still correctly model the motion of the dart in the air. Now the difference of using this method is we use proportions. So we say, how does each variable change in the equation when we go from the original to the new? If it stays the same, we represent it as a 1, or if it's a constant, we represent it as a 1. So in the original equation, delta y was just the original height. So we're going to call that 1. Now that's a proportion, so it means it was 1 times the original height. So it is the original height. So we say 1 equals, now 1/2, that's a constant. So we want to make sure to leave that as a 1, okay? Anytime you have a constant, if it's like 4, 1/2, 3, pi, any constants we leave as 1. The acceleration. Now in both cases, the acceleration is negative 9.8. So that's a constant for our problem too. So we're going to say that changed by a proportion of 1. And then we're wondering, how does the time change, right? The question is how much longer. So we're going to leave that in variable form, t squared. So if I solve for this, I get t equals 1. That's good. You should always get 1 for your original. You know you're doing it right when you get 1. And what that means is that the original time is 1 times the original time. That should make sense, right? Our original time should equal the original time. Now when it gets interesting is when we go over to this new way of doing it. So the new one is twice the height. So where I see delta y, instead of 1, I'm going to plug in a 2 for that because the height doubled. So 2 times bigger is equal to, don't forget that when you see a 1/2, that's a constant, so we plug in a 1. That's honestly the biggest mistake people make when they do this method. So that's a 1. The acceleration is still that constant negative 9.8, so that's a 1. And then we're trying to figure out how does the time change. So whatever variable they're asking about, you leave in variable form. So now I can solve for this, and I'm going to find that time for the second one is √2. And what that means is time is √2 times longer than the original. And so just the same answer we got from the first way of solving it, using proportions and equations, we can see that when the height is doubled, you get √2 times longer in the air. Awesome. Thanks for watching. Have a great night.